Okay, so in this video we're going to do a quick review for the expand and condensing logarithms quiz. Okay, so let's look at the first problem. You will have to expand with the directions here, expand each of the following, and you will have to condense, and I'll show you those directions in just a moment. Okay, so when we look at this, remember that we have to view this in order of operations. So we have this exponent, and I can't touch this product until I deal with this exponent. So power rule says that I can bring this exponent down as a multiplier, so as a coefficient. So 2 times log base 3, 27 x to the 1/2 times y. Now here, the next thing, remember when we are expanding, we're looking for multiplication, division, or exponents, and we're going to take them in the other direction. Okay, we're going to write them as addition, we're going to write them as subtraction, and we're going to write our exponents as coefficients, okay? So the next thing I notice is that my entire argument is all multiplication. So 27 times x to the 1/2 times y. And we know that multiplication is commutative, so that means that I can go ahead and write this as the sum of all 3 of those logarithms. Now remember, these parentheses here are super important because that 2 does in fact go to everything in those parentheses, because that 2 is raised to everything in the parentheses. So that's 1/2 plus log base 3 of y. Okay, so then I go through the process, the 3 rules. Do I still have any products? No, I've got 27, x to the 1/2, and y. No products. So do I have any quotients? Still no quotients. Third, do I have any powers? And I do. I have 1 exponent left, so I'm going to need to fix that. So 2 times log base 3 of 27 plus 1/2 log base 3 of x plus log base 3 of y. Okay? So now I have no products, no quotients, no exponents. But the last thing I have to do before I say I'm done is look at my bases and my arguments to see if that logarithm will simplify. So remember, it will simplify if the base to some exponent will give you this argument. Okay? So 3 to some power, will it give me 27? And the answer to that is yes. 3 to the 3rd power will give me 27. So remember, log base 3 of 27 is equal to 3. That equal sign means they are interchangeable. They are equal, so I can put a 3 in place of log base 3 of 27 because it is equal to 3. 1/2. I can't raise 3 to anything and get a variable, so I'm going to leave it. And again, I can't raise 3 to anything and get a variable. Okay? And now I'm done. Okay, so again, I have no power, so I'm expanding. I have no power on the outside, so I don't have to deal with that first. So the first thing that I'm going to deal with here is the quotient. It would be too difficult to try and break that product up before I did the quotient. So I'm going to have log of 7x squared minus log of y cubed. Okay, so I'm going to go through my process. Do I have any quotients left? No. Do I have products left? Yes. 7 times x squared is a product, so I need to go back and write that as a sum. Okay, so again, I'm going to go through the process. There's only 3 rules: product, power, and quotient. So do I have any products left? No. Do I have any quotients left? No. Do I have any exponents left? Yes, I have a 2 and a 3. So I need to fix that. So I have log base 7 of 2 log x minus 3 log y. So again, before I call myself done, I'm going to make sure that none of my bases, none of my logarithms will simplify, and I check that by seeing if the base to some exponent equals my argument. So remember, if we have an unspoken or an unwritten base, it's an understood 10. So 10 to some power, some whole number power, is not going to get me 7. 10 to nothing is going to get me a variable, and 10 to nothing is going to get me a variable. So I am done. Okay, so then you will have to condense, and I just noticed that I made a typo there. Condense each of the following. to a single logarithm. So our goal in condensing always is to get to either a single logarithm or a single number. Okay, so I'm going to work first with order of operations. I know I have to fix these exponents because if I start combining product and quotient first, then I'm raising that exponent to more than what it's supposed to be raised to, because this 3 only goes to that 4 and this 2 only goes to that x. So if I'm multiplying it by something else, then I have done things out of order. So I'm going to have log of 4 to the 3rd minus log of 8 plus log of x squared. So I have no grouping symbols at this point, so I would likely go ahead and work this from left to right. So I'm going to simplify. 4 to the 3rd is 64 minus log of 8 plus log of x squared. Okay, so from left to right in order, I'm going to do quotient rule first, the subtraction. And quotient rule says I can write 2 subtracting logarithms as the single logarithm of their quotient. Okay, now again, I'm going to simplify here. 64 divided by 8 is 8. And the last thing I have left to do is I still have addition, which tells me that that is product rule. So I can write this as a single logarithm of their products. Okay. So again, order of operations, I'm going to deal with all those exponents first. So I have log of 81 to the 1/4 minus parenthesis log of 2 to the 3rd plus log of x to the 3rd. Now the grouping symbols this time, those parentheses tell me I have to do what's in here first. So I'm going to do some simplification in my arguments before I do my parentheses. So 81 to the 4th is 3 and 2 to the 3rd is 8. Now I'm ready to do what's inside those parentheses. So I have log of 3 minus the product rule says when I add 2 logarithms, it's the single logarithm of their product. Okay, so that leaves me with subtraction, which is the quotient rule. So that's going to be 3 divided by 8x cubed. So again, much like expanding, you stop and you go, okay, do I have addition, do I have subtraction, or do I have a coefficient? And I don't, so I know that I'm done.